We're going to be looking at quadratics in vertex form. With quadratics, we've kind of dealt with a quadratic before. This is in the form of an x squared, so anything that has a x squared is considered a quadratic. Vertex form specifically is in the form of y equals a x minus h squared plus k. A determines the direction of the opening as well as whether we have a stretch or a shrink vertically. Now, looking at the h and the k, if we were dealing with our transformations, we know that the h is opposite of what we see, and that's going to tell us our left and right. The k stays where it's at, and that's going to determine our up and down. Our vertex, which determines our min or our max, is located at that h comma k. So you might want to make a little note that h is opposite of what you see, just as a refresher. Now, we're just going to talk through a little bit of this and look at the graphs and what information we can pull from our graphs. So, if we were to have y equals 2 parentheses x minus 3 squared plus 4. Now, if I don't have the graph of this, there is information that I can pull from this. So the first one is going to be my vertex. From my vertex, it is located at 3, 4. Again, h is opposite of what you see. The a value is going to be a 2. This tells me, because it's a positive a value, that this parabola is going to be in the up direction. Therefore, my vertex is a min. Okay, so you might want to write this down as well as some additional help. Okay, so from that information, just looking at the equation, we have a lot of information off of that. The other thing that we need to talk about is the axis of symmetry. The axis of symmetry just determines where your parabola, if you were to cut it in half, where it would fold up and match up perfectly. That line is based off of your vertex. So this is axis of symmetry. Where does the parabola have a reflection? So the reason why I say this is based off of your vertex is because the axis of symmetry is going to be whatever your x coordinate is for your vertex. So in this case, our axis of symmetry is actually going to be located at x equals 3. So let's actually look at the graphs and see, what it is, what characteristics we can find off of our graph. So for instance, this is just my normal y equals x squared. Just to kind of look at that a value and determining our stretch and our shrink. If we have a number less than 1, notice the branches of the arms got wider. Okay, so even though it technically is a shrink, our branches actually got wider. So that's something that you might want to make a note of. All right, now let's look at the y equals 4x squared. Notice that branches got closer to the y axis there. And just as a refresher here, remember that that negative in front is going to reflect it over the x-axis, which we've talked about before, and you guys can see that it actually flips. Now, let's also look at that last example we had. And let's look at it in terms of, we found the vertex and the axis of symmetry. Okay, so I'm going to take these off. So again, this is information. We just had it on, just on paper, the vertex and all of that information. Now we're just looking at the graph of it. So this is everything you already have down. You can see here that the vertex, this point here, is located at that 3, 4. And again, that just shows up to show us that, we did have a min. Looking at that graph, it does show us that we have a min. If you click on it, you can see that it does match up. That 2 actually makes the branches go more narrow again, and that tells us our direction of the opening. We can see that our parabola is facing upward, and if I were to put in the axis of symmetry line, which is x equals 3, you guys can see here that looking at my parabola, that line, that axis of symmetry, cuts my parabola exactly in half. And that's, again, just based off the x-coordinate off of the vertex. The other thing that you would be looking at with a parabola in terms of what information can we pull off of the equation is you could also pull the information off of our domain and range. So with a parabola, if we have a minimum here of 3, here's the thing with parabolas or quadratics. Domain is always negative infinity to infinity, unless there is some type of restriction that they tell you ahead of time. The range. This is going to be determined by your vertex. So without even looking at the graph, my range, if 3, 4 is my minimum, that means that that parabola hits that point at that 3, 4 and has to keep going up. So that means that my range, again basing it off the y, is bracket 4, infinity. Now if you were to have a maximum, you'd have it the reverse way. So it would be negative infinity to whatever that y coordinate is of your vertex. So this is information based off of your standard form. There's a lot of information you can pull from just the equation alone in order to determine what the graph looks like.